Welcome to my online class again. In computer, I did measurement and control. In this topic, we are going to learn about DC motor and servo motor. After the previous week, you already know how to generate the pulse width modulation. Now, this application of pulse width modulation, especially in DC motor and servo motor. Let's begin for an objective. In our objective, of course, to understanding the pulse width modulation and analog input or output or input using Arduino Uno. And the second one is learning how to deal with the DC motor and servo motor. The devices requirement devices in this lecture is of course Arduino Uno, and you need also potentiometer, and of course DC motor, and also you need the DC motor H-bridge or L293D, and also servo motor. This kind of module already available in your Arduino kit, and this one is kind of a small DC motor. We call it that this is a micro DC motor, and this also micro servo motor. All right, so we are first discuss about the DC motor first, which is the micro DC motor. The basic principle of DC motor is actually, as you know, is the based on principle of Laplace force. When the wire carrying an electric current, where is the wire, and the wire is placed in magnetic field, which is there is a current flow axis in the wire, and there is in the molecular particle in the Q, it means the current flow, there is acting the Lorentz force in the microscopic scale. And this kind of based on the right hand rule. This one is current flow or current direction, and there is the this one is a magnetic field in this direction, and when you place this wire in the magnetic field in this permanent magnet, there is also magnetic field, and there is the acting magnetic force, which is the equation in physics. Basically, force per length of wire is equal the cross product of the current and magnetic field factor. Okay, so if you have this one is left hand rule, this one is a magnetic field, and this thumb is a force, and this finger is the current flow direction, Okay, this one is basic principle of DC motor. And when you place this the stiff of wire, this kind of wire, if you put the direct flow of current, this one is direction of current. Okay, this one is positive and this one is negative. Maybe it's more clear. This one positive and this one negative. The current will flow from here, and the current will go through here. Based on the physics, when the wire is inside the magnetic field, there is a force acting on the wire. It's called the Laplace force. So this kind of the armature, we call it this armature, which will rotate in this direction. Okay, this one is magnetic field, and this one is current, and there is a magnetic force acting in this armature, and this call it the commutator. This part, this piece of the how to say this one, plate, and this also call it the brush. This one is call it brush, and with after this rotation, this also same thing acting the force, so this armature will rotate continuously. Okay, maybe delete these things. Okay, for brush DC motor, if you open the motor, you can see this one is armature, the windings, the rotor windings, and this kind of plate, copper plate, you call it, this one is a commutator, maybe using laser point, commutator, and this one is a motor winding. Winding is consists of the copper wire in here, and this one is call it the silicon steel lamination. This call it also we call it the armature. Here is same windings or armature, and this kind of the rotor is placed in the middle of the permanent magnet north and south. So based on this principle of the Laplace force, you can rotate these windings continuously. When does this current direction is changing, the rotation of direction also changing. For example, if this one is positive now, if this you give this one become negative and this one is positive, reverse direction, and maybe this rotation previously clockwise and become counterclockwise rotation. That is principle of DC motor. I think it's enough. This is basic of DC motor. And from your textbooks or your in module Arduino kit, you have kind of a tiny micro DC motor which is volt. The maximum is 3.7 volt. It is the ideal voltage input for your micro DC motor. But also you can put in give the 5 volts also, but be careful about this one. Maybe I don't know, maybe can be more heat or generation can be damage your motor, or maybe more than 5 volts. You have to aware of this motor. So in this in your textbooks there is the kind of the voltage input in here, and maybe this one is a current rating in milliampere, and this one is maybe this one is power of volt multiply current, and this one is RPM, maybe for this motor. All right, let's go to first experiment for this DC motor. In this picture is very simple experiment. This one is your DC motor and with the propeller, and just give the positive to pin 5 for timer 0, I not mistake, and this one is ground. So just give to pin 5 for pulse width modulation, and put in the plug into red for DC motor and ground, and blue wire for DC motor. In this case, we just drive directly from pin 5 for DC motor. This one actually not recommended for driving DC motor, but anyway, this one is good for basic driving using pulse width modulation is fine because your DC motor is has a small voltage input. I mean the voltage power rating, very small. And I think this one just okay. Let's discuss about the code. And this one is the kind of constant for pin 5. You already know. And in void setup, you just give the serial begin. This one standard for serial communication in serial monitor, and print the serial to give information the how much level PWM you giving in the serial monitor. And in void loop, just give the variable value. We have a variable value int in here, and if there is a available character serial available, just detect the integer value and give this store in the variable value. And then we already learned about pulse width modulation in previous lecture. You just write the analog right, and this one is a PWM pin 5, and this one whatever value from 0 to 255 in here. Okay, and then just print out how much value of the you giving from serial monitor, and just give the delay. Okay, I will show you now in my DEX. I already have motor rotation. How to go the okay, just minus this one. In my DEX already has this one, and this one is code in previous PPT in similar PPT, but the connection we have to set for 5. I think just upload this one. So rotation motor will stop. This one I just put given the previous code. I just connect the cable from this one. The white is a ground, and I use the connection for pin 5 PWM. There is nothing happen because you don't give any value for serial monitor. So you just go in here. As you can see, there is the enter PWM level because you type in here serial print ln enter PWM level 0 to 255, and just enter value. This one is maximum value, and you can send, and the type is no line ending. As you can see, the motor is rotate perfectly in here, and you give the maybe 100, or 125, the speed will reduce slightly, or 100. The rotation of the DC motor will reduce, and you can reduce more. This one is 80 or 60 PWM value, or become 40. The minimum, I think 50 or 10. Use a lower value. The minimum, I think 25 or something. The motor cannot rotate with this value. Okay, this is the PWM basic principle when you drive directly using pin 5. But actually this one is not recommended as long as maybe your motor, as long as your motor has a low power rating, I think it's fine using directly the pin timer as the output. Anyway, this one is for experiment 1. You can see if you enter again for maximum value, the motor will rotate maximum full rotation. Okay, I hope you understand. Okay, this one is for experiment 1. For experiment 1 also, still for page 210 in your textbooks. In this case, we enter changing the voltage. In here, you just changing the enter voltage 0 to 5. In this case, you have another variable. We call it the voltage. Within the data type is float. So if the serial monitor available in here, serial.available, bracket and close bracket, and this one voltage, you give in from the serial monitor from 0 to 5 and give in here voltage, and then you just give a command to output to print again voltage, and then there is the conversion to value from voltage to 255. In here the conversion plus 0.5 maybe for compensation of the conversion from float, maybe from float to integer. Anyway, you print and then analog write. This is pin 5 using timer 0, I think, and this one is value, which is conversion from voltage to decimal value 0 to 255. And then in this command, print the value of the conversion from example, and then delay. And from example in here, if you give the voltage 5, and this one voltage 5, and the output value is 255, of course, and this, if you give a 3.5 volt, the output the decimal value is 179. And this also, if you give the 2.5, and the output value is 128, decimal value of the analog right in here. Okay, this one is just picture. I guess this one is not video. Okay, this one is from your textbooks, and this one is comparison in your textbooks. Maybe somebody measure in this, and this variation of variable decimal for pulse width modulation from 0 to 255, and with a comparison without propeller and with load with propeller, which is the voltage is slightly drop from here. Without propeller, the voltage is if you give the voltage pin 5 volts is about 4.6, and this one 3.9, and you give the voltage from the PWM pin, the voltage will drop about 3.85 volts, and this with propeller the voltage is around 1.5 volts, and so on. I think this one is not ampere, this one is mistake. I think this one is milliampere, should be aware. Milliampere. I think this one also milliampere. Maybe somebody is wrong type. 74.5 ampere is very big ampere. You can damage the motor. Anyway, this one is the ideal voltage output with the pulse width modulation input. But anyway, as you know, there is a voltage drop. The voltage will reduce based on the decimal value. This one is current, and this one is also power, and this one is explanation of the variation of when you give the, I think this one is also same. It's ideally 5 voltage. If you give the what is this? Anyway, there is the voltage drop with the ideal without when you give the input the DC motor. I think this graph is enough, you understand properly. Anyway, for experiment this one, we have to do this one. You can upload this program similar in your textbooks. Anyway, just as you know, just upload. Error, you have to close the serial monitor. And now in here, I have to give the input voltage. How much you want? Maybe 5. It will give the maximum rotation. And as you know that from the table in here, the voltage will drop significantly around 1.5 voltage, because we drive directly using the PMWM. The voltage is around 1.5 volt. It's not the maximum performance of this motor because there is a voltage drop, but this one is not recommended for driving motor. Oh, I decreased the voltage. This one 4.5, become 4. This one is 3.5, become 3. This one 2.5. I just want to know how much the minimum voltage this motor. I think 1 volt. 0.5, I think not rotate. I think it says 1 volt is the minimum voltage for motor can rotate. Anyway, we can go to next slide. For second experiment, I just took from the textbook page 211. In here we drive the motor, DC motor, with a similar pin which connect directly to red, and this one ground also, and we just add additional potentiometer. In here in potentiometer, the voltage input, we use the analog 0, analog input 0. And of course in potentiometer, remember, you have to give the voltage also and also ground for potentiometer. This one is schematic diagram for DC motor, directly pin to 5 and ground also, and this one is also ground. This one, the yellow wire is A0, 5, go to 5 for potentiometer. Let's check the code. It's nothing special, I think. In this code, first we have to define constant. Of course, this one is for input, output for DC motor, and this one input for potentiometer. In void setup function, you set up the serial dot begin 9600 for serial communication. It is standard. I think this one is very easy. You already know. And the void loop, we declare in here statement of two variables. First as input, and this one is decimal value for analog write. From input, from potentiometer value, this one is analog read. As you know, you already learned in previous lecture with analog read, and then select the any. In this case, the pin port is analog 0. Okay. I think just leave it the noise, and the value is the mapping value from potentiometer. As you know, potentiometer is analog input is 10 bit. Okay, to power 10 is about 24, or in range 0 to 1, 2, 3. I think using yellow color is better. It make a harmful eye. Okay, anyway, this one is a conversion from 0, 1, 2, 3 to 0 to 5, 5. You already know using map function. Okay. And then this one, you just give the value PWM for motor. And this one is just a serial monitor output, which is you give the display of PTN input equal standard, and use this one is dots tab, this one is for tab, and this one also tab, and this one you type output for PWM and type again, and this one then value for PWM from 0 to 255. Okay, so input 0 to 1023, and then delay. Understand, right? Very easy. I think this one is very easy for you. So this one is video I made. When you rotate the potentiometer, the motor will go or rotates maximum and reduce the speed becomes 0. This one is a serial monitor output. Increase the rotation to maximum value, and then decrease rotation to 0. And this one experimentally I will discuss later. And in here I already attached the potentiometer in my DeX, and using similar code in PPT I already explained. I think it's nothing special for you. This one constant definition, and this one is serial communication in void setup. And void loop, just read the potentiometer, this one potentiometer, and using mapping conversion from 0 to 1023 into 0 to 155, and then you move or rotate the motor, DC motor, continuously based on the value of the potentiometer value. And this one is just output for serial monitor, and there is a delay in here. Oh, okay. And select a port, and you can upload in here. In this case, potentiometer is I connect in this DeX using A1. I connect A1 in here. There are two connections in here. Okay, just upload. Okay, let's rotate the potentiometer. This one is 0 value. Maybe open serial monitor. Oh, the input is about 10. Okay, you cannot see. And then we can rotate this one slowly. Okay, this one is around 2 volts, I think. and then rotate to maximum value. In here there is a voltage drop in here for voltage from potentiometer. Maybe the maximum value is not 1023. So anyway, you can see in here the maximum, you have the value and decrease and then 0. Okay, not 0 actually. Anyway, that one is using potentiometer. Okay, for next experiment is for explanation on using edge bridge. I just took the picture from this engineering site, engineeringgarage.com, for this picture. Previously, we just drive the DC motor unappropriate way. This one is appropriate way. Properly, we usually drive the DC motor using edge bridge. Previously, using directly PWM, edge is not recommended actually. The best way using edge bridge. In this case, using edge bridge, you can drive variation of typical of the variation output of the motor in range or low voltage to high voltage. We call it edge bridge because the shape of this bridge circuit like a H alphabet, like this H, like this H. So sometimes people just call it edge bridge because the similar at edge bridge. In the your module there is the dual edge bridge. We call it this kind of chip we use in your module. This one L293D. This one is for channel 1. For edge bridge we use 128. I'm sorry, 127, and then for channel 2 using this pin 9 to 15. I will explain first. L29DC is actually edge bridge circuit with 2 channels, dual, or we call it dual edge bridge. This kind of type of chip can be used to drive unipolar or bipolar stepper motor. You already learn how to drive stepper motor, right? DC motor or even servo motor. This single channel can be used to drive DC motor in clockwise or counterclockwise. Okay. Basically, we can drive the DC motor using edge bridge, which this one is equivalent half bridge. Edge bridge, which is when you give the input, there are 2 kind of switch in here. This one is analogy for input 1, switch 1, and this one input 2, switch 2. And this enable is the pulse width modulation. signal, which is typically using 5-volt voltage, and this one is source of motor voltage. And in this bridge, usually there is a transistor PNP or transistor NPN. In here, whatever, when the input, you give the input 1, it means this one is switch is closed, or this is 0. Maybe this one, what's happened, this one connect directly to the ground. So maybe this one is will active the circuit, maybe go to this way. So the DC motor will drive counterclockwise. In here, when the switch to active, this one on input 1 is closed. Maybe this one, the current flow will go through here. So this one become positive and this one become negative. This one is analogy for edge bridge. This one, when you drive for clockwise, you should give the close the input 1. So this one is will become, the current flow will go through from here through here. So this one motor will rotate clockwise. And when for motor counterclockwise, you should off the input 1 and on input 2. Select. So the current flow will go through here to here. This is a call it edge bridge. Okay. This one is a proper way how we drive the DC motor, usually using edge bridge. There are another, in your textbooks, there is another type of driver. We call it this one L298 in your textbooks. That is also edge bridge. And in this case, we use the 293 series. I wish you understand my explanation. I'm sorry, I just want to next. So for edge bridge experiment, edge bridge experiment, this one is for wiring connection, and we still require the potentiometer, which is giving input to A1, input A1, and here I change the color, and this one is Arduino chip, Arduino chip, chip. Okay, this one is driver L293, which is the enable is the PWM. In this case, we connect to timer 1. I wish there are timer 0 is 5, 6 pin. This is 9, 10 pin, and timer 2 in Arduino what? 11 and 3. I wish I remember this one. If correct me if I'm wrong. I think this one is using timer 1. Connect this one 9 to pin 1 for chip 1. In this case, there is a symbol like this. Remember which one is a 1, and if this one is a symbol like this. If you see previous slide, there is type is symbol. This one is a mark symbol, and this one a dot. It means this one 1. So this one 2, 3, 4, 5, 6, 7, 8, 9, 16. Okay, you got it. Very easy. It's not difficult. Okay, again in here in chip connection, this one is input 1, pin 2, 4, pin 5. Okay, this one is input 2 and 7, input 2. Sorry, this one input 1, this one input 2. This one pin connect 6. Connect to pin 6. And also we need to require the switch. This one. Switch 11. Pin 11 and connect directly to ground. And this one chip also need the ground to ground in here. Oops. Okay. For chip L29D, pin 3 and pin 6 is the output to motor. Sorry. Motor. DC motor. Okay, very easy, right? So again, this one is BMW pin. Connect to pin 1. I type in here pin 9, pin 5, pin input 1, pin 6, input 2, and pin 5, 6 is connect, pin 4 and 5 connect to ground, and 3 and 6 is output to motor, DC motor plus and negative, whatever. And your potentiometer connect to A1, which is the connect to 5 volts and also ground in here. And remember, for this chip input motor, I use the 3.3 volts. In here, 3.3 volts connect to pin 8 for L29 3D. And also you need the voltage source in here to here, 5 volts. Anyway, this one is, I think you understand this wiring connection. I wish you understand the connection of this experiment. Okay, for the code, firstly you have to define constant. In here you already know pin 9 is for PWM, and input 1 pin 5 for input digital, and also pin input 2, pin 6, digital output, and button switch is 11. Remember? And in here, we use potentiometer in analog input 1. And then we need the global variable data type int for speed. We call it motor underscore speed, which is a range from 0 to 255 decimal value. And then you have in here Boolean data type and static Boolean data type, which variable name is direction or dir. In this case, I define equal true, which is true is equal 1 and false is equal 0. Okay, and then we define in here void set motor. I think this code is similar with the page 29217 in textbooks. I think similar. I just giving the different code with the yellow color in here. And in here there is the set motor function, which is input data type motor underscore speed variable and data type direction boolean. Okay, in this the analog write, you just giving the motor PWM, which is pin 9. Pin enable is pin 9, which is the value whatever you give the in here, the value motor speed, you just give the analog write, give the input motor speed from 0 to 255, and then in here just a definition of direction, clockwise or counterclockwise. In this case, because it's output, so pin 5 or pin 6, this one is definition of 0 or 1, vice versa. For clockwise, in here, digital write, pin 5. If the direction is true, this one is not true. So this one is 0, digital write, pin 6, 1. Okay, maybe for counterclockwise, digital write, 5, 1, digital write, 6 is 0. Just simple like that. This meaning code simple like this. Okay, in void setup, you set for serial communication, and this one for input pin 5 and pin 6. Okay, for input 1, input 2, and then button pin 11 you set for internal pull-up resistor. Remember, for internal pull-up resistor, this one is pull-up means resistor is above, this one is switch, this one is ground, this one is input to Arduino, this one is pin 11, which is actually this one is 5 volts already inside in Arduino circuit, so you just give the directly pin 11 to ground, and then switch and activate input pull up. Okay, and then in void loop we do rotation continuously again and again in void loop by reading the potentiometer value analog read. Store the value to integer variable, we call it value in here, and then using map function conversion from 0 2023 to 0 to 55, 0 23 conversion to 0 to 55. That is the motor speed in this range 0 to 55. And then we detect if the button is pressed, you just change direction. It means if state of low, of course, in this pull up resistor, change the color. This one is resistor. Remember, pull up resistor. Pull up means above. This one is ground. If the switch is this one is false. It states if switch is open means high, and then when the switch is closed, and then this one is direct connect to ground, so this one 0. This one is pull up resistor, remember. So the code is when the switch is pressed. When it's pressed means connection. This connection is become 0 and state is become low. So when if switch is pressed means state is low, change direction. In here, direction variable giving the value. We just name it the not. This means direction equal not. So this one the value 1 becomes 0, or when the value 0 is becomes 1. Okay, and then just giving the time to stop motor for 1 second. And then in here, there is the callback function. We call it set motor. We already declared in this set motor, which is motor speed. We already know the range is from 0 to 255, comma, Boolean direction, which the value is only 1 or 0. In here, direction, whatever it is 1 or 0, give the input for function set motor, and then serial print. Serial print, you just display motor speed from 0 to 255, and then display the value variable of motor underscore speed variable, and then finish. That is the code. I think similar with the in the book. I just give the some kind of different things in yellow color. I wish my explanation is you can understand and don't feel boring with this class. Okay, so this one is changing by rotation of potentiometer. Motor become maximum full rotation. This one using H bridge. You can see this chip, and I press the switch to change the rotational direction. of the motor. Okay, this one is display of the PWM value from 0 to 55. I think it's enough for this video. Let's do from in real condition. I'm sorry, this one also real condition, but I just show again in the here. This one I already installed similar connection wire diagram, similar in this PPT. Using A1 and pin switch is 11. Okay, everything is remain the same. So this program is similar in PPT. Okay, I just connect again in H-bridge. Count 5. Okay, now the motor speed is shows about 2 decimal value. If we rotate this motor, we start from rotate from PWM about 20. This one is slow rotation. You can press this button to change direction. Can you see? Maybe increase the speed. This one is maximum speed of the value, not 255. Maybe there is voltage drop on it from potentiometer. You can change this value of direction. Just like that. I wish you like it and you don't feel boring with this experiment. Oh, what happened? I clicked something. Okay. That is the code. Control the motor speed The lowest one is about 28, 20, very fast. I think 27, 28. And change direction. Just like that. Okay, I think it's better. Go to next experiment. I wish you understand my explanation of the code. I will explain again. In this case, constant variable definition, and this one is function of set motor, which is input the motor speed from 0 to 255. Hello. 0 to 255, and this Boolean direction is value is 1 or 0, which is true is 1, false is 0. Okay, this one is analog write. There's a PWM output pin and value from 0 to 255, and then digital write output, this one between 5 or 6, which is even 1 or either it is 1 or 0. It is a void setup. It is a serial begin. This one is setup for serial communication. Of course, it's very easy. As you know, this one is output 5 and pin 6. Pin 5 and pin 6 output. Pin 11 is internal output for switch. And in void loop, you read first potentiometer and using map function, changing to range 0 to 255. And then if button is pressed, change direction. Of course, if the digital read pin button equals 0 or equal low, change direction. And then giving time to stop motor with delay 1 second. And then you set in here motor run continuously with the depends on the value of the potentiometer and also direction. And then this is just give the print on the serial monitor motor speed PM W M, this motor speed variable. Sorry, this one is button function. We already learned in here in previous one. I put the button. Maybe you need that when the motor change direction. And we set motor whatever value from potentiometer and also direction from switch. And then in here we do while for counting for the blade. That's on timer. We don't need this count in here actually. So in while loop, is get the time for millisecond, which is count time for millisecond, and we run the function of blade counts, which is the how many counts in here. And then if the time already 1 second, means the time already 1 millisecond or 1000 millisecond, I mean time minus all time. First in the code we set all time is a 0, means when this time get 1000 bigger than reference time, this one is we define 1000. If more than 1000, more or equal 1000, just go breaking loop, just define break loop out of while loop. But don't forget, put the all time is equal time. Again, store the time variable to all time variable value. After count the blade, we have variable count 1. In this case, for calculate the RPM, you can see also check it in the textbooks. It's also same function, which is how many blades in 1 second. Because this millisecond, so you just divide it 1000. So change the second, this one conversion to second, and divide it how many number of blades we have. In this case, we have 2 blades. So divide it 2. So you can get how many rotation per second. To change the rotation per minute, you just multiply 60 by conversion of the time. And this one is just the display of the how many counts and tab. This one is tab. Sorry, this one is tab. And display speed in RPM. We have this variable. Okay, I think this one is for RPM measurement. I use my code to calculate the rotation per minute, how many blades is given. Okay, I hope you understand. And this one is video. And this blade should be placed between the IR LED and our reservoir. In here, this one kind of rotation measurement, and how many counts we get the value of number of blade from the measurement, and we can estimate RPM of this motor. All right. Okay, the next servo motor I will explain for this experiment. This one is code is similar with in the PPT, which is the define the time, number of blade, define a constant, everything of pin anyway, and the variable motor speed value and time also, and in this function blade counts, and you just read the analog input from the IR reservoir or IR potentiometer. I mean photoresistor, phototransistor. I mean this one is phototransistor or IR detector. Okay, and if the value is 0, it means when the blade is blocked the IR light, you just count how many blades, number of 0 you have in time, and then return the count, and it means return the result of your count number. And this one is moving motor, we already know in this function. And then for its setup, serial begin, set the 5 and 6 pin and pin switch, and this one IR output, set continuously, IR LED always on, and set first all time is equal 0, and in void loop first reset count, and we read the potentiometer value and store in variable value in here, and in motor speed we convert the value from 10 bits to 8 bits, means the 0 to 1023 to 0 to 55 using map function. And after that, this one is just detect the switch in here and run motor continuously in here, and this one is looping for counting. We use the function of millis to get time in millisecond. Okay, this one is count, just run function of blade counts, callback function blade counts. We count how many blade or how many 0 is the analog 0 in here. This one count blade counts. Okay, and if time is equal minus odd time more than equal 1000, means that if this one difference time bigger than 1 second, you just break up the loop, out of loop. So store again in time equal all time variable, and then repeat this function again after you do this. And this one calculate RPM. Okay, and then display RPM. I upload. In here RPM is 0, of course there is no blade is counting in here. And if I move this blade in the middle, you will get the value of the number of blades in here, because this IR light is blocked by the blade, and you counting how many blades is for 1 second. The rotation for DC motor is not stable, of course, maybe due to PWM input. Anyway, you can estimate this rotation. Actually, in this video, recorded very slow rotation, but actually this is very fast rotation. In this video, it looks very low rotation, but actually this is very fast. Okay, anyway, that one is experiment. Or you can change the RPM more lower. Oh, I destroyed. So now the RPM about 1900 RPM, and you can changing the direction of the speed. I think it's failed because this there is the time delay for calculate counting 1 second, so maybe switch is not detected. So anyway, you can change it the switch by pressing more longer for more than 1 second and change the direction of the blade. Okay, that one is experiment 4. Okay, if you have any question, you can ask me in contact. I hope you understand this RPM measurement. You can see very beautiful measurement. But if you increase speed more higher, of course, you cannot detect the number of blades because it's too fast. Detect this how many blades for this motor. See, this is kind of problem. Of course, this has problem because this IR LED is low speed, so there is a limitation for this measurement. Anyway, we finished the topic for DC motor. For servo motor, I will continue for next video. This servo motor, micro servo motor, I will continue for next video.